full screen, right?
Yes, Kader, we can
Okay.
see.
Fine. So I think this is our sixth or seventh session. I'd like to, thank you guys for having a mindset of continuous learning, because that's a big thing for me to see, and also for the community that we work together to ensure every single person gets that, gets that intention, gets that urge to continuously learn and become successful, right? So that is what we are keen on, and that's what we wanted to really achieve. Thanks to everyone who has been supporting us to achieve that. Some quick logistics here. Let me see if I can actually paste it in the chat. Okay, where is it? So if you, for some reason, if you wanted to reach out to us, you are welcome to reach out to us on a couple of email addresses. Those are in the chat right now. That's the first logistics. And then the second logistics related I wanted to talk about is Testoper is a non-profit organization. So any donation from anyone is welcome. And if you wanted to donate, this is the link, but not mandatory. Anyone is interested, please feel free to. And make sure that we have another 5 or 6 sessions almost. A lot of good things is going to happen in future sessions. A lot of good learnings that we're going to do together. Make sure that every session, future sessions, you do not forget to register. You can do it immediately after the session as well. But some I know that whatever it is, some of us are lazy like me. So what I do is I normally create a bi-weekly recurring calendar in my Outlook, and then I just put this link so I can join without registration, even though we recommend you all to register. But still, if you prefer this as one way, feel free to copy these links. These are the 5 key links that are important to know from the logistics point of view. Okay. And going back to the session, see, that is my window. Okay. Going back to our session, just a quick recap. So Yokesh today is going to talk a little bit more depth on the user plane. And it's more oriented towards developer. He would be occupying last, I would say, 20 minutes of the session, 20 to 25 minutes of the session. As you know that this session is organized in such a way that it's the combination of the domain knowledge with the practical hands-on developer / tester / operation experts knowledge is what we have structured this whole continuous learning program for. So the first few minutes today I would be talking on technology. So one of the things that I wanted to focus today is on the standards, right? Standards is a little dry subject, but I will see how I can tell only enough so that you know the basics and you are able to further develop on that, right? So that's my thought process. And what did we do so far? In our session, we have considerably achieved a lot of things, right? Even though this is our 5th or 6th session, we have achieved a lot of things. We have learned basically, now let me go back to this agenda. Apologies. Where's the agenda slide? Okay. Give me a second here. Maybe I opened the wrong slide. Just wanted to double check. Okay, got it. No, I'm in the right slides. Just need to go to the right place. Okay, awesome. So, right. So what we basically why we are trying to really do this is 2 things, right? So one thing is we have to build our expertise, and you can build that only through the continuous learning, right? And these sessions are going to really help you from domain as well as from the hands-on experience point of view. But for hands-on, we need to choose some open source to start with. And we decided to choose Magma, which is an open source, a converged open source for 4G and 5G. And we are focusing on 5G SA, right? So that's number one. And then the second reason why we are doing this session is also for you to understand the end-to-end picture. And we would be seeing a lot of sessions in future where you would learn a little bit about integrating radio to the core network, learn a little bit about integrating BSS to your core network, and integrating the SIM management to your core network, how this complete end-to-end together as a system it works, so you can actually deploy the end-to-end network, right? So that's what we mean by understanding a big picture through the different ecosystem that's involved within the blueprint to understand the big picture, right? So that's the second reason. So it's not about only understanding the domain and understanding the practical experience on some open sources, but also have a feel by end of the session how this whole end-to-end network works when it comes to 5G. And we can also show some demo on 4G as well. So you get some kind of a good understanding of whole thing, how it works. Okay, so that's what we wanted to really achieve in this session. Moving on. So the agenda, we have achieved a lot of things so far, right? I'm really, really proud of. We have learned the domain knowledge on wireline networks. We have learned the domain knowledge on wireless networks from olden days all the way to the 5G, and even we talked about 6G. And the third topic we would probably today focus on, it's a little bit dry topic. I'll see how interestingly I can cover. So it's very important to understand the standards and open source, which is what we will talk about, picking few standards, standard bodies. And then the fourth one will become a little bit more interesting, right? And the fifth one will become a little bit more interesting. So that I'm reserving it for the future sessions. So in adjacent technologies, what we will learn is how analytics and AI is going to play a role, right? In communication industry, how a blockchain is going to play a role. What is the basic fundamentals of blockchain, right? What is AR and VR? How all these different technologies, introduction of all these different technologies, how all these different technologies come together and play a role in the future networks and future connectivity networks, right? And future communication networks. That's what we would probably learn in adjacent technologies. And we will also learn about NFVs, the difference between NFV and SDN, why NFV, why SDN, what's the difference between NFV, SDN and cloud, right? What is a public cloud, private cloud? So all those different adjacent technologies, if not to its depth, but at a very high level, we will learn how all these different things comes together in the blueprint to achieve the end-to-end network. But end of the day, when you finish this session, 12 sessions, right? Or when you go back and review all the videos of these 12 sessions, we expect you to really understand the big picture, and which will allow you to get into the depth when you require to get into the depth, and also have an hands-on experience and have a feel of end-to-end network understanding. That's the goal, okay? And I'm really very proud that we have achieved almost like 45% of what we wanted to do, and remaining 60% to go. And I'm excited to continue this journey for next 5 to 6 sessions to complete that storyline. Okay, so moving on. So we talked about wireline and wireless, and I'm not going to repeat it. I just wanted you guys to actually go back and look at the videos that is in the YouTube to learn more on this, right? Whatever that we have learned in the previous session. But one thing that I would like to really share before I start this today's session on the standards is that, when you look at end-to-end network, right? These are the two slides that I wanted to really, talk a little bit before we get into the standards. So the 5G network can be deployed for mass deployment, right? So like how we are using 3G and 4G, you can use 5G to do a number of things. You can have a higher throughput. You can download the videos and movies within seconds, right? So those kind of benefits that's going to provide you as an individual. But it also will provide you, in addition to that, the 5G is designed to provide you benefit for person-to-machine and machine-to-machine communications, right? And there are a number of use cases, whether it is a very basic internet browsing to the AR, VR. Nowadays, it's called as metaverse, and distributed, disaggregated, decentralized economy, right? Which is what called as blockchain. So all these different technologies really require a very stable, high throughput, low latency network that can allow you to build different use cases, products, solutions, whatnot, right? So the key message I want to give you is that you can either deploy all these services in a public network through network slicing, which we talked about in our previous session, or you can deploy a dedicated network. Okay, a dedicated network that can allow you to deploy for different use cases by yourself. Okay, so this is the key message that I wanted to share it with you. And that's what this last slide that we were talking about, right? So you can deploy all these different use cases built on different technologies in either public network, or you can have your own dedicated network. And depending upon your use case and your comfort level, your economic model, your business case, you have a flexibility to choose them. Right? So that's the key message that I wanted to share. And now why I did share this is because it's kind of related to the standards as well, right? So in telecom, what happens is historically everything is built on standards. That's the only reason why interoperability happens, right? You take your phone today and you go to some country in, let's say in Philippines, and you still can use your phone as how you have been using at home, right? So that's the interoperability that we are talking about. So all the communication networks are highly interoperable networks, mainly because it follows the standards, and the products are built based on the standards. So when two products are integrated, whether it is from the same company or whether it is from the multiple companies, right? Both the product works. That's the key message that I wanted to give you. And having said that, let's jump into the standards and open source discussion for today. I'll pause here for a minute to check on my volume and everything is okay, guys.
Yes, Karthik.
Yes, awesome.
It's fine, Karthik.
Perfect. I'm just timing it. So make sure that I'll try to finish this by 9, in another probably 10 to 15 minutes, as much as I can, and then I'll hand over to you, Yokesh, on the second chapter. So when it comes to the standards and open source, so I mean, like I mentioned, in the past, it's always standards, right? So standards are followed and companies build products based on the standards. So it's all interoperable globally. And the open source is a new dynamics. When I say new, it's not new today. I mean, compared to the standards, it's a new dynamics where people come together and start building something that can be used by everyone to commercialize and build business around, right? So it's whenever I talk about open source or a word open, to me, the word open always brings innovation, right? And the open source community, evolving towards building communication products is the biggest, I would say, change in dynamics in the way that we see world today compared to the way that we were seeing the world many years ago. Right? When I wanted to learn, in my early days, anything on communication, I need to work on companies who are actually building the products or, for communication industries. So it's very difficult for me. But now today, if I wanted to learn RAN, I can join Open RAN community. If I wanted to learn BSS, I can join Bill CRM. There are so many open source communities, right, for OSS and BSS. If I wanted to learn assurance, there are so many open sources around that. If I wanted to learn simulations, testing, there are so many open sources out there. If I wanted to learn core network, there are so many. I mean, you name it, right? AI, artificial intelligence, AR, VR, blockchain, everything is now open source. And that basically reduces the barrier and enables all of us to innovate, right? So the open source, in other words, is an innovation. So it's very important nowadays. You need to really understand not only the standards, but also the evolutions of different open sources that are happening in communication industries and how they both are related and how all these things come together. It's very important for you to understand. Okay, and you will be learning that some today, and you will learn some in our next session. But I want to make sure that you understand this. This is the background of why it is critical for you to learn about standards and open sources, what's happening in the communication/connectivity industry. Okay, so now we'll start with the very basic standards, right? So ITU is the standard that defines, okay, guys, it is called as International Telecommunication Union, right? So they basically say, hey guys, this is what we wanted to do for next 10 years and next 20 years, next 50 years, right? So they basically define the roadmap of, okay, 5G means this, right? 6G means this. Then what happens is there are a number of different standard bodies that are out there, like ETSI and many ATI, many standard bodies that are out there. They start building the standards, right? But sometimes before it used to be like for European they used ETSI standards. For Americas they used ANSI standards. If you go back in olden days, right? Even in TDM, 24 slots, 32 slots, all these differences, right? Before it used to be like, but now what has happened is like all these different standard bodies have over the period of time came together. Like GSM standard bodies were building the 2G, 3G standards, right? But then eventually what happened was all these different standard bodies came together and they started something called as a project, right? And then that project started building the standards. So one such project is called 3GPP, right? Third generation project, partnership project or something, right? And that organization started building the standards for 4G and 5G and moving forward for 6G. So that is what the 3GPP standard is all about. Now, when you take a step back and see from the 5G point of view, it all started in 2015. It's not today, right? It's 7 years old technology as such, right? But it's still as fresh as it is today, and there are still so many things that has to be developed and so on. But the definitions of what the 5G is from the 3GPP point of view, what kind of a use cases it will solve, everything started around 2015, and there was a document, that was built. It's 22.891, I guess. Yeah, 891, and it defined 74 use cases. And then what happened was there was another document which was defined, which kind of categorized all those use cases into 5 major areas, right? The broadband, low latency communication, machine type communication. Then the fourth one is in operations, and finally vehicle to everything, right? So all the different use cases are merged into 5 major areas, and then the requirements around these 5 major areas started evolving, right? And then those requirement documents started evolving, 21 documents, right? And then from then on, the multiple other documents started evolving, right? From the requirements to definition, to actual protocol definition, and so on, right? So there are, in 3GPP, it's called a stage 1, stage 2, stage 3. So as you go into the stage, there is more details are defined, and you learn. So, but when from your point of view, a good place to start is to understand a big picture. Start always on the requirement, right? Stage 1, and then get into the stage 2, a little bit of logical definition, and then stage 3, where actually the protocols and everything is defined in detail, right? So that's what it is that I wanted to share it with you. And it's very difficult to, it's very easy to kind of navigate through that standards. It's not very difficult. Most of the time what we do is we try to go and Google and try to find the standards. Don't do that, right? Because just go to the source, right? And it's very easy to identify the standards that you wanted to look at and learn from it, and go to navigate through that and identify the right standards and right section, what you wanted to look at it. It's pretty straightforward and easy. So all you have to do is go to this 3GPP org, and then you click, sorry, I have a bigger window. You click the specification, and then you click work plan item, and then you will actually see what you see here in the screen, right? And if you look into the screen, let me check if I can make it a little bigger here. Yeah, if you can see the screen, you would actually see, in the right-hand column, it's a little bit small. All towards the right, there is a release 1, release 17, release 18 that you see here, right? And then you see priority 1, 2, 3, that's stage 1, stage 2, stage 3 kind of a thing. Then you'll also see some code name for different features. Then you will actually see the description of the features and the numbers, right? So basically, when you open this, what you can actually see is that from the historically and also today and future, the complete picture you can see. So what kind of features are implemented in release 15 in the past? I'm just taking an example. What kind of features that are worked upon right now in release 17? What kind of features that are planned to work on release 18, release 19? You would actually see that classification very well in that section. Now, the features, right? Let's say if you're interested in network slicing, you can just search network slicing and then you can identify what is the tag name on that network slicing. Like for example, URLLC, you can see the tagline here, 5G URLLC, and then you can just go and filter that URLLC. Then you will understand these are all the different features that are built from release 15 to release 17 to future release 18 and 19 on URLLC. And you will see the description of the feature, you will understand. Then if you wanted to understand which spec it is actually defined, stage 1, stage 2, stage 3, that will also be listed here. So you can look at it and then you can open that spec and then you can go to that section and you can learn. So that is how you navigate through this standards, and navigating the standards and learning, understanding what features are getting developed in the standards is very critical for you today, in the past, today, and in future. We don't have to know the details, but at least go through this once, right? Like half an hour. It will give you a better clarity and better, expertise than Googling and reading in multiple places. Okay, so do this exercise. You will remember me saying this. The power of it you will learn after you do this exercise and spend some time on that. Okay, all right. So that is 3GPP. Then you would also see number of standards. I don't want to pick all the standards, but I wanted to pick few standard bodies, right? They are more specific to industries. They are more specific to supporting customers, right? So this number of organizations are there like that, right? So like, for example, 5G for automobile, there is a different organization. I think it's called as ACA. I'll look it up and I'll probably let you know in the next time, right? And likewise, 5G for industrial 5G, there is a organization called ACIA, right? So like this, there are a number of different organizations that take that 5G stuff that's defined in 3GPP and then try to bring that to a specific industries or a specific domain, right? So it's, when you Google it, you can actually, if you want to find out who is doing that for automobile, you will search it, you will find it, right? So what I took here as an example is to really help you guys to understand from the connected industry point of view and in the manufacturing floor point of view. The ACIA is an organization that basically defines how 5G can be utilized for industrial purpose, right, in the manufacturing floor. So here, just these two slides is what that I wanted to cover, but I wanted to take a 5 minutes to slowly explain and help you guys understand, right? So when you talk about 5G, we talked about person-to-person communication, then we talked about person-to-mission and mission-to-mission communication, right? So the person-to-mission and mission-to-mission communication is very critical in the manufacturing floor. When I say a manufacturing floor, it could be a pharma industry manufacturing floor, which manufactures the medicines for us. It could be a aeroplane industry or farming industry, which produces food for us. And it could be anything, right? But this manufacturing floor, where a lot of different industries have that produces different goods and services for us, is, if you look at that architecture of that particular organization, this is how you see it, right? From the communication point of view. So the first one is an IT one. First one is a public domain, network domain. Every organization have to have an access to the internet, whether it is through fiber or whether it is through satellite. It doesn't really matter, right? They need to really have some kind of a connection. If the farming industry is somewhere in the remote, probably they'll use satellite for connecting to the internet. So that's your public domain. And then every company has an IT domain, right? You have in your organization, you have computers, it's all networked, and you're protected by firewall and from outside attacks. So there's an IT domain which is going to be there with the number of softwares that supports us to do that, right? There's number of softwares like CRM. There's number of things that you deploy in your IT domain to provide it to your employees to use them. Then in the manufacturing floor, there is another domain which is called as an OT domain. That's nothing but in the manufacturing floor, whatever you have, that's what is called as an OT domain. So now let's look at what do you have in the manufacturing floor. Okay, so what you have in the manufacturing floor is, obviously you need to have a network, right? And it's called as an OT domain. And in that network, you can, in the past, you used to have a lot of different types of networks, right? I mean, in those manufacturing floor, it's a little bit detailed, but I'll try to explain. They sometimes call it as a class A Class B, Class C kind of networks, right? So Class A basically you uses a little bit higher level layers. For them, the higher level layers is like Ethernet and IP, Modbus, TCP, and all those kind of things. So Class B is you use Ethernet. Ethernet frame-based communication happens, right? Some of the protocols like Profinet, EtherCAT, those are used for Class B kind of communication. And then Class C is like a hardware layer 2 level communications, right? So there you have like, again, EtherCAT, Profinet, IRT, CC-Link. There's so many protocols that are used. So the reason I'm explaining this a little bit detailed, but I'll come back to the abstract. So Class A, Class B, Class C, different types of communications that all used to be wired communications in the past. And depending upon different use cases, they choose what Class A, Class B, or use case requirements and communication requirements they choose. Should I go to Class A based wired network in the manufacturing floor, Class B based, Class C based, right? So the more you go down, the more reliable it is. Right, so that is network. Before it used to be always wired network. Now 5G, like I mentioned, is built ground up to support person to machine and machine to machine communication with advanced features like connecting millions and millions of devices within the square meter and connecting, low latency, providing a low latency network with time synchronization network. TSN is also very important. If you wanted to provide a solid manufacturing floor communication network, time synchronization is also very important. 5G also has that embedded into its architecture, right? Which is defined by IEEE. So 5G could be a good network that you can use within the manufacturing floor to replace these, wired-based network, which was not an option before, right? For some of the critical communication. If there is a communication that you need in a manufacturing floor that is just a business driven, and you can still use 4Gs and Wi-Fi's and things like that, right? But when it comes to the business critical and mission critical, 5G, considering its architecture, will play an important role. So that is the network point of view. I wanted to kind of explain a little bit there. And then you have an application, like how you have in how you have it in IT, different applications like CRMs, billing, like Zoho's, in multiple companies we have in Wave Labs we have Zoho, and you have many applications that are sitting, Outlook, Word, whatever in the IT domain. Like that, there are so many specific applications that are required in the OT domain to run the manufacturing floor, right? Some of them that I can explain what you see here, like for example, MES that you see here, it's called as a manufacturing execution system, right? And then you have a PLC here that you see here, programming logical control. PID, I think it's called, it's a proportional integral device. So these are, and then you have SCADA, right, which controls, it collects the data, controls and collects the data in the manufacturing floor. Let's say when you're manufacturing the cars in your manufacturing floor. Then you have sensors, actuators, control modules. So all these are the devices that communicate with each other through the network to all these systems, right? Digital twin, AI, predictive maintenance, energy maintenance, supervising and monitoring. All these systems are very much required to run this manufacturing floor, right? So the devices and applications communicate through the network. And also device to device is communicated through network, peer-to-peer, right? So these are all the different things that actually makes up the manufacturing floor network, right? Let me just kind of summarize this. You have a public network, then you have a traditional enterprise network, then you have a OT network, and within the OT domain, and within that OT domain, obviously you need a network. Before it used to be a wired networks, Class A, Class B, Class C. Now with 5G, you can actually replace them because it provides, in some cases, better than those wired networks from the point of view of reliability, availability, or whatnot, right? And then you have to have a means of making sure different machines to machines are communicating, and machines to applications are communicating, and machines to peoples are communicating. And the network is basically something that enables that. So now if you are able to understand this particular explanation, right, then the second one is what happens within this manufacturing floor, right? It's not like a normal thing. It's like you need to have a high availability, 99, multiple nines, right? You need to have really, really high availability, and communication time should be very less. Latency should be very, very less. And packet payload types are very small. It's not big like normal network browsing. So that means when you design your product, you've got to design your product with very small packet sizes, payload sizes, and it has to run 24/7 without breaking, period, right? Without breaking, and it has to connect number of devices. Positioning accuracy is very important. If a robot does not have a good positioning accuracy, instead of placing a car door in the car door place, it will probably go and place it in the engine place, right? So it's very important. Accuracy is critical, and time TSN synchronization is very, very critical. And different types of traffic can happen within person to machine and machine to machine. So these are all important characteristics of anything that you do in the manufacturing floor, and the communication has to really support that. Okay. And if you have to divide the multiple areas within the manufacturing floor, you can kind of divide this into multiple things: factory automation, process automation, human machine interfaces like GUI, production IT, which is what some of the applications that I showed you, logistics and warehousing, monitoring and predictive maintenance. These are some of the areas. And the top, what you see is some of the use cases that are defined by ACIA. And the point I wanted to make here is that this table is a little bit very detailed for you to understand, but you can always go back and look at the presentation. But the message I wanted to give you before I hand over to Yokesh is that every area that you have within the industrial floor, within the manufacturing floor, and every use cases that you have within the manufacturing floor, from controlling the robots, right, motion control, to AR, VR, to process monitoring, to asset management, to making the robots move and do things, right, will fall under one or other use case of 5G that I talked about in my first slide, right? It could fall under the broadband use case. It requires high throughput. It can fall under low latency use case, which requires low latency. It can fall under a lot of connecting machine use case. It can fall under a service assurance use case, operations and maintenance use case, and in some cases, it can even fall under the vehicle use case. If you're building a vehicle in a floor that will go in the manufacturing floor, in other words, an agricultural floor where the food are produced, right? So that's the message I want to give you. Anything that you see, it will fall under all those 5G based use cases. You will be able to map those 5G based use cases against the industrial use cases and build your products and solutions in such a way that it can do what it is intended to do. Okay, so just to summarizing, so what we learned today is a general standard, 3GPP standard, and then we looked at a specific body who is defining, taking the inputs from 3GPP and defining what is that required for connected industries, for industrial automation. Like this, there are a number of organizations which does that. I just took this as one example. You as an individual, you can always go on Google, hey, what kind of an organization is available for digital twin for 5G? What kind of an organization is available for automotive for 5G? There are a number of organizations like this that are available. Depending upon your interest and your focus area and your continuous learning area, you can go and develop your skills from there. Okay, so I'll pause here for any questions. And I need to give now floor to Yokesh for 20 minutes to close the session. Any questions, please? Hopefully it was helpful for every one of you. These are very, very critical to know. These might look very simple, but if you wanted to really grow your career and want to know the big picture, these are important for you to learn. So with that, what we will do, we will hand over to our second half of the session to Yokesh and his team, where hands-on developer related stuff is going to be discussed more from the point of view of user plane. So Yokesh, floor to you.
Sure. Thanks, Kader. I think that information was quite helpful. Today's session, I'll be running with Lavanya. So what I will do first is, I'll just give a quick overview of what we covered till now, and Lavanya will actually show the demo for the past part. So just give me a second. I'll share my screen. So I hope the screen is visible.
Yes, Yokesh.
Okay. Yeah, so I think till now what we have covered was the basic components, the registration procedure, the video session procedure. So this, this is just a summary of what we captured till now. Uh, so just from the call flow perspective, let's say UE wants to start a communication. Let's say you are powering on a device, or you are coming out of airplane mode. So UE will get itself registered with GNB, and then GNB along with UE data and its own data will send messages to AMF via N2 interface. So here there is no direct connection between UE and AMF. Everything goes via N2. That's why it's a dotted line. But basically, it shows that some of this information are GNB specific, some are UE specific. So UE powered on, it gets itself registered. The security, authentication, and other components or the other state machines take over, and we establish that this UE is legitimate. He is authorized to use our network. So the basic registration is done. Then there is a PDO session. So where UE actually wants to make a communication to, let's say, google.com or whatever some website. So then there is a PDO session which gets created. Again, that request comes to GNB, validated by AMF, SMF, and then there's a dedicated channel which is provided. So the packet from UE will land on to GNB. GNB will put some extra headers. We'll give it to UPF, which is our the topic of agenda today. UPF strips off this GTP header and other things, put the packet on the wire towards the internet. And on the reverse side, same happens, like it's UPF will put on the GTP header, goes to GNB, back to UE. So this we have covered more or less in our previous sessions. Um, it's like a little scary. I don't want to go through all the components, but yeah, just wanted to show you. These are the different components of a DATAPATH stack, where you have a UDP port, the L3 port, and then there are some components of the radio side, and we have the UPF, where you have Ethernet, IP, and other layers, which will support G2P tunnel going towards the internet. This is how a packet looks like when the packet lands on to UPF from GNB. So basically, on this big box, when the packet, there's an uplink packet, let's say going to google.com, where it lands into the UPF fast path. It will have its own identifiers. And based on these identifiers, the quality of service and the forwarding rules will be applied onto the packet by the UPF. Then these additional headers will be removed because it was only to just identify and forward the packet and provide the quality of service. But basically, this is how the packet looks when it actually goes on to the N6 interface, which is the internet. This is the N6. So as Kader was mentioning, so there are specs for every interface we have, like N6, there's a spec, N3, there is a spec. So this N3 packet will have a GTP header, N6 will be a pure IP packet, and the same packet will land onto the internet. Yeah, so I think more or less we have covered all the portions in some of the other form in our previous discussions, but I just want to summarize it here. Lavanya?
Yeah, thank you, Yogesh, for the introduction and summary. I'll start sharing my screen.
So I'll stop here.
So yeah. So yeah, good evening, good morning, everyone, depending upon your time zone. So today I'll be talking about OVS data path and our user plane space in Magma AJW and how we pipeline the packets which are coming from the UI side and move it to the internet. So starting with the agenda of this slide, like meeting, I'll start with the Magma data path and I'll introduce like what is OVS and what is how we have built the tech stack and how we are pipelining the data packets. And after that, I'll introduce the OVS commands which we frequently use. And then I'll also introduce what are the OVS flow tables that are relevant for developer. After that, I'll introduce the traffic generator, that is iperf3, that we use for the testing purpose, how we can run it, and what are the commands for that iperf3. Then after that, I'll end my presentation with a demo, working demo, that it is a recorded video, but I'll show that to you. So yeah, moving on. So Magma data path. So Magma gateway pipelines the packet by utilizing the Linux network stack and OVS. So right hand side, as Yogesh already showed in his slide, like how this whole packet traveling happens, like what is N1, N3 interface and all that. So I have just made it simple that this G node B sends the packet to the kernel space, and then this OVS bridge is controlled by basically this, and this is controlled in the user space by user space OVS vSwitch flow table, and which is in fact flow table rules are implemented by the pipeline D of Magma, that is our UPF component. So yeah, OVS, and coming to Open vSwitch or OVS, it is a multi-layer software licensed and like having an open source Apache 2 license, and it is well suited to test things in virtual setup as well as in real setup. It can expose standard control and visibility of interfaces to virtual networking layer as well as like the bare metal also. So yeah, moving on to the OVS commands. So there are two very important commands which developers should be aware of. The first one is OVS vsctl show command, which prints every brief overview of the switch contents. So it tells us what is the name of the interface that are being created, and if there's any issue also, it will reflect that. So it basically prints a brief summary about that what are the Open vSwitch configured. And the second command is used to print the flow entry of a particular table, or we can print the flow entry of all the tables, relevant tables also. So there are 20 tables, and there are 4 important tables for a developer, and I'll be covering that in the next slide. So in the table ID, we can replace the table ID with the table number, and we can get the output of that this whole flow entry. So yeah. OVS tables. So there are 4 important tables as I said before. So the table 0 is the ingress table, or the table which captures the packets, information of the packets which are coming to the Magma AJW from the UE side. And then we have this table 20, that is the egress table that captures the flow entry and everything for the packets which are leaving the Magma AJW side to the internet, or like our traffic server if we have installed one. And table 12 is our QoS flow table. So it gives us the information about what are the policies which we are trying to enforce, and we can have a look at that. And table 13 is the matrix table. So basically our Magma has this orchestrator component which we use for monitoring purposes. So the information that is fetched by the orchestrator regarding the data users and other things are in fact forwarded by the information of table 13. So yeah, so moving on. So iperf3. So iperf3 is the tool which we use for active measurement of maximum achievable bandwidth on IP networks, or basically it is a traffic generator as well as testing tool. Like one side we can test the traffic which is sent, so we can create a client server kind of model, and we can do the throughput testing using iperf. And it can test the bandwidth loss and other parameters which are relevant for a developer. So it is based upon, like, it is, we can call it a successor of Hyper, but it is not backward compatible. So if you have integrated Hyper with your existing software or anything, so it will not work with that because it is a completely different tool than Hyper. So yeah, Hyper commands. So the installation of Hyper 3 is pretty simple. We can install it using sudo apt install. It is part of standard Linux package and Ubuntu packages. So we can directly install it from the command line using this sudo apt install Hyper 3. Then creating the client server. So then I'll be explaining this in a bit detail in the next slide, but just for the like introduction, the IP3 minus S, this IP address is how we create the server, and the second command IP3 minus C, then add this IP address, is we are creating a client and we are sending the traffic to the this first created server. Minus B, this IP address is the interface which will be binding with the client, and we will be sending the traffic through this particular interface. Minus U means that we are trying to send the UDP packets, and minus B 200M is the like how much this bytes of packet we are trying to send. So 200 MBs of packet we are sending. So yeah, coming to the next slide. So demo setup. So in the this left hand side, GNB UI simulator, we have installed IPO3, and in this internet, we are actually trying to replicate the internet or simulate the internet using another VM, that is a traffic VM called Magma TRF server. And here also we have installed IPO3, and we will run the first command, that is IPO3 minus S, and that IP address command here in this VM, and then we'll trying to send the traffic through this this first VM. This is AJW is our Magma AJW VM, which is in fact connected to the orchestrator, and that table 13 information is then sent to the orchestrator for the users reporting and users monitoring purposes. So yeah, before I move on to the demo, I want to share some more facts about it. So the current setup which I'll be going to demonstrate is a very flexible setup. So Hyper3 and I'll be using in this setup Hyper3 and OAI sim, as we have like OAI sim we already have demonstrated in the last sessions. But if you are using any other simulator also, that is also that can also be used instead of OAI sim, and Hyper is also compatible with that. So yeah, seeing that, I'll move on to the demo. Yeah, so I'm bringing up the OAI GNB sim UE and GNB respectively in this. So this part is already covered in our last sessions, how to bring it up. Yeah, now the PDU session is established. So this is our first VM, that is the simulator VM, and then I'll be checking the if config, and we can see that a new GTP interface is created, and through this interface only we'll be sending the traffic. So OAI turn UE is the interface which has been created, and it has this particular IP address 192.168.128.30. So we'll be sending the traffic using this. And this is our Magma TRS server, which we are using to simulate the internet. So if I'm checking the IP, like what all interfaces are available here, so I'll be using the eth2 interface to create our traffic server. So this interface has this IP address 192.168.129.42. So I'll be creating that IP3 server here. So yeah, this command I ran, and the server is started to listen on port 5201. Now this OVS flow tables, I'll be dumping the table 0, that is the ingress table, just to show you what is the current status of the table and what are the packets that are involved. Okay, sorry. Yeah, just a second. Starting server here. Checking the entries in table 0. So yeah, we can see these are the entries. So the first row in this table tells us the uplink information. So number of packets sent are 4. So I have some testing before that, so that's why this number of packets are 4. And the second one is the downlink. So this number of packets are 0. So the moment I start sending the traffic, we can see a change in this entries. So now I will be sending the traffic using hyper from our first VM. So IP I have to set it as 13. Right now it is 12. So because this IP is 13, this is the UE's IP that has been allocated by the AGW. So yeah, now we can see the difference in the entries. So here we can see the n number of packets were 4. Now it has become 2428. And similarly, the number of bytes has also changed. And in the downlink one, this n packets is equal to 0 was there. Now it has become 8. So this is our table 0, that is the ingress table. I'll be showing the next tables now, that are QS tables and that matrix table. So here also we can see that server has received and the test has been completed. So now I'll be showing the other tables, that are table 13 and 12. So this is our QS table. So all the policies and the flow rules that we implement, we can see it here. And the table 13 is the table which is the matrix table that further gives the information to our orchestrator, and then we can see it in the Grafana dashboard and other places. So I'm again sending the traffic just to show you that how table 20 changes. So initially this table 20, this in table 20 there is one thing to note down is the first row is not relevant. The uplink is the second row, information is in the second row, and the downlink information is in the third row. So we can see it was 11774 because of our previous testing, and this now it has become 13574. Similarly, this 45 has become 53. So yeah, moving on with this. So yeah, that was pretty much it. I So yeah, this is all about doing a throughput testing using Hyper and OASM, and and we need in this we used a TRF server. So I'll again do a summary for everyone that in this presentation we had a look at how Magma's pipelines is packet to internet, and then what is OVS, what are the important OVS commands, how can we install the OVS, and what is hyper 3, what are the important commands for hyper 3, and then we had this demo where I showed you how to check out the OVS tables, and if there's any problem with the data path, this is how we debug it. So we check out the table entries, we check out whether traffic is actually reaching the OVS or not, and then we debug the data path. So yeah, thank you everyone.
Thanks, Lavanya. What I would say is, as our sessions are going, we will be covering only the data part. So if you have any questions and queries, please post us. I hope all the previous installations and the steps were clear. If there are any questions, please let us know. Thanks, Lavanya, once again. Back to you, Kader.
Thank you.
Thank you. Thank you, Yogesh. Thank you, Lavanya. It's a great job. I really appreciate it. I just want to put my LinkedIn for those who are not connected with me. Please connect with me on the LinkedIn. Let's chat offline to see how we can continuously learn from each other. What else? It's a long weekend in Canada. In spite of that, happy to see so many people joined. And thanks for all of you joining today's session. Looking forward to you all joining in 2 weeks next session to learn more and more in coming future topics. Thanks, guys. You all have a wonderful day. Take care. Bye-bye.
Bye. Bye.
Thank you.
Thank you, everyone.
Thank you all.
Thank you.
Thank you all.